In section 6.3, we are factoring trinomials of the form ax squared plus bx plus c and perfect square trinomials. Our objectives are to factor trinomials of the form ax squared plus bx plus c where a does not equal 1, factor out the GCF before factoring a trinomial of the form ax squared plus bx plus c, and factor perfect square trinomials. Now it's important to note that the first learning objective, we're going to be using the trial and error method for factoring, or it's also called the guess and check method of factoring. In section 6.4, the very next set of videos, we will be using the grouping method or the AC method. Now, you can choose whichever method you're most comfortable with in terms of factoring out trinomials of the form ax squared plus bx plus c. Again, we're using that trial and error method in section 6.3, and then later in section 6.4, we're going to be learning the grouping method or the AC method. What it comes down to is you use the method that works best for you. You can practice both, and then you may find that one method is more suited to you than the other. Let's complete each factored form. We begin with the trinomial 3x squared plus 8x plus 4. One of the factors is already given to us as 3x plus 2, and we need to find the missing factor. The way to think about this is that in this trial and error method or the guess and check method, the check part is going to be using FOIL, the first, outer, inner, and last. So the first term will give us the 3x squared. The last term would give us the plus 4, but the outer and the inner combined will give you 8x. So let's look at how we would determine the first term of the second factor. If we have 3x, we want to multiply that by something to get the first of 3x squared. So that must be x, because we know 3x times x is 3x squared. The outer and the inner are tougher to find because we know that they have to add up to 8. And the last term is going to be a plus 4, and we know that this second term here is a plus 2, and we want to multiply it by the term here to get a plus 4. And that would be a positive 2 times a positive 2. So this is what we are guessing, that doing this trial of 3x plus 2 as one factor, then x plus 2 could be the other factor. But it is really important to check your work here using the FOIL method. And doing that, we have 3x times x would be 3x squared. The outer is 3x times 2 would be plus 6x. The inner is plus 2x, and the last is plus 4. By combining those middle terms, we see we have 3x squared plus 8x plus 4, which is what we started off with. So we know that we have correctly found the other factor. So again, this guess and check method, you definitely want to make sure you do the check step. These problems are more challenging because the first coefficient is something other than 1. So you can't use the method that we did in 6.2 on these problems. For example B, we have 2y squared plus 7y minus 15, and one of the factors of 2y minus 3 is given. We've got to find the other factor. So I know if I look at the first would be found by multiplying the first term of 2y times the first term here, and that's going to give us the 2y squared. So we're going to have to multiply that by y in order to get the 2y squared. Now the last is going to be the negative 3 times this quantity will give us the last term of negative 15, and that's going to have to be positive 5, because we know negative 3 times positive 5 is negative 15. So we want to say that the factors are 2y minus 3 and y plus 5. We don't want to say for sure unless we check our work here. And using the FOIL method, we're going to multiply 2y times y to get 2y squared. The outer 2y times positive 5 is 10y. the inner is negative 3 times y, or negative 3y, and the last is negative 15. When we check this by combining the middle terms, we get 2y squared plus 7y minus 15. You want to double check that this is exactly what you started off with. So by checking that, we know that the factors are 2y minus 3 and y plus 5. What's nice about these two problems is that they give you one factor, and you have to find the other factor. In the next examples, you're going to have to figure out both factors, and there's a lot of trial and error, guess and check, that will have to go into factoring those problems. Let's factor each trinomial completely. Example C is 2x squared plus 7x plus 3. I want to find the two factors. Since it's a trinomial, we can usually factor it into two binomial factors. And we want to look at the 2x squared. That would be the first times the first, which should give us a 2x squared. So perhaps one of those terms is 2x and the other term is x. So because we know 2x times x is 2x squared. Then we have to look at the last term here. The last term times the last term should give us a positive 3. So there are a couple ways to do that. It could be a positive 1 and a positive 3, or it could be a negative 1 and a negative 3. So let's try the positive 1 and the positive 3. So we can guess that our factors are 2x plus 1 and x plus 3. But we definitely want to check this to make sure we end up with the right factors. By using the FOIL process, we know that 2x times x is 2x squared, 2x times 3 is plus 6x, the inner is plus 1x, and the last is plus 3. By combining those middle terms, we do get this is the same thing as what we started off with, so we know that our answer in factored form is 2x plus 1 times x plus 3. In example B, we want to do the same process using that guess and check method, trial and error method. I know that the first term is 5x squared, and I can get 5x by having a first term of 5x and a first term in the other factor of x. And then so that I know that 5x times x will give us the 5x squared. Now in terms of getting the plus 6 here, I know that positive 6 can be found by multiplying positive 1 times a positive 6, or even a positive 2 times a positive 3, or even a negative 1 times negative 6, or negative 2 times negative 3. So we want to find the right pair of factors that will end up in the FOIL process giving you a middle term of 17x. So let's begin by checking the first pair, a positive 1 and a positive 6. You do want to check this by using the FOIL process. 5x times x would give us 5x squared. The outer 5x times 6 would give us a plus 30x. The inner would give us a plus 1x, and then the last would give us a plus 6. However, when we combine like terms here, we get 5x squared plus 31x plus 6. And what we're looking for is a middle term that is a positive 17. This is not going to work. So the factors in this form of 5x plus 1 and x plus 6 is not the right combination of factors. So we need to try something else. Let's try 5x plus 6 and 5x plus 1. Again, we have to use the guess and check method. Sorry, that should have been 5x plus 6 and x plus 1. By using the guess and check, we do the FOIL 5x squared times 5x plus 6x plus 6. But when we combine the middle terms here again, we only get 11x. So we don't get the 17 that we're looking for. So we got to do this again. This perhaps may not be the most efficient way, but it is one way. If you can stick with it, you will be able to find the correct pair of factors. Let's try the positive 2 and the positive 3 here. So when we do that, using the check method of FOIL, 5x times x gives us 5x squared, 5x times 3 is plus 15x, the 2 times x inner is plus 2x, and the last is plus 6. By combining the middle terms, we get 5x squared plus 17x plus 6. And thankfully, this does give us the correct middle term. So our answer in factored form is 5x plus 2 times the other factor of x plus 3. In example E, we have 8x squared plus x minus 7. So we want to find the pair of factors that when you use FOIL, you would end up with 8x squared plus x minus 8. Now there are a lot of possibilities here in getting that first term. We know that the first term and the first factor multiplied by the first term and the second factor must equal 8x squared. So there are a couple ways of doing that. You could either have 8x times x. You could also have like a 4x times a 2x, and so on, or the other way around. Now we'll begin with using the 8x and the x, and if none of those work, we'll go ahead and use the 4x and the 2x. Now to get the last term, we have a negative 7. The way you get negative 7 is you can multiply a negative 1 times a positive 7, a positive 1 times a negative 7. And you can also have these in any order. So we want to check, let's try a positive 1. Let's try a positive 1 here and a negative 7. But in this process, we must use the check step here. It's not going to work without doing the check. So when we do the check, we can multiply the 8x times x, first outer, inner, last, 8x squared, minus 56x plus 1x minus 7. Well, I know that those two, when you combine them, will not equal that a positive x. So that we can say right away, that is not the right factored form. So let's try another pair of factors. Let's try 8x, let's do the minus 7 and then x plus 1. So I've kept the first terms the same and then just rearranged the second terms. Doing the first outer, inner, last, I can multiply 8x times x to get 8x squared. The outer is plus 8x, the inner is minus 7x, and the last is minus 7. When you combine those middle terms, you get 8x squared plus x minus 7, which is what we started off with. So we know that our solution, in factored form, is the quantity 8x minus 7 times the quantity x plus 1. I want to point out here that there were other possibilities that you could have come up with. You could have used 8x minus 1 and x plus 7, but if you check that, that's not going to give you the right middle term. You could have used 8x plus 7 and x minus 1. Again, when you do the check step, that's not going to work. You could have also used 4x plus 7 and 2x minus 1. And there's a few others that you could have tried. So it's really important. There's a lot of possibilities here. Using the trial and error method, the guess and check method, is you definitely want to check your work. In example F, we have 20r squared plus 31r minus 7. Now here these problems get to be quite challenging if you're using the trial and error or the guess and check method. So if you get discouraged using this method because there are so many possibilities, I encourage you to move on to section 6.4 after you go over the special factoring of trinomials and use the AC method. You'll find that it's much more systematic and it really reduces all that trial and error method. But suppose we want to factor this. We want to find the pairs of factors that will give us 20r squared plus 31r minus 7. There's a lot of possibilities here. For the first term, we could have 20r times r. We could have 10r times 2r. We could even have 5r times 4r. And then for the second term, because when you multiply the first terms, you want that to equal 20r squared. So those are the different ways that that can happen. And then looking at the last term, you want to be able to multiply the last terms together to get -7. And you could have a positive plus or a +1 and a -7. You could have a -1 and a +7. You could have them in a different order. You could have a +7 and a -1, or you could have a -7 and a +1. So there's a lot of different possibilities here, and you're just going to have to take the time to go through and guess and check. And again, if you get discouraged, move on to the AC method, which I'll show you in section 6.4. So I've done quite a few of these doing the guess and check method, and I found a pair that works. So I find that one of the factors is 5r minus 1, while the other factor is 4r plus 7. I do want to make sure this is the correct one by using the check step. Using FOIL, 5r times 4r is 20r squared. 5r times the plus 7 is a plus 35r, and then minus 4r minus 7. By combining the middle terms, you can see that we do get that 31r minus 7. That's really an important part here, is that you want to make sure that that middle term is correct. So the answer, the factored form of that trinomial, is the factor 5r minus 1 times the factor 4r plus 7. Let's look at example G. The trinomial 6x squared plus 19x minus 11. Okay, so we've got a lot of possibilities here on how we can get the 6x squared. We could have 6x times x. We could have 3x times 2x. And then we've got some possibilities here for getting the minus 11. It could be a +1 and a -11, a -1 and a +11, or a +11 and a -1, or a -11 and a +1. So you want to go through those possibilities until you find one that works. So I've gone through the possible pairs and combinations to get 3x plus 11 as one factor and 2x minus 1 as the other factor. And we're going to check this by using the FOIL. First, 3x times 2x is 6x squared. The outer is minus 3x. The inner is plus 22x. And the last is minus 11. By combining the middle terms, we get 6x squared plus 19x minus 11. So we can say that is what we started off with. That middle term of plus 19 is the same as what we had in our original problem. So the correct factored form is one factor 3x plus 11 and the other factor 2x minus 1. In example H, we have 3x squared minus 7x minus 20. So we've got a lot of possibilities here. For 3x, you could have 3x and x, okay? And then for the minus 20, you could have a +1 and a -20, or a -1 and a +20. You could have 2 plus or minus 2 times a positive or -10, a plus or minus 4, and a plus or minus 5. So again, quite a few possibilities. You want to find the one where the outer and the inner will give you the -7. You could also look at these factors of -20 as a plus or minus 20 and a plus or minus 1, a plus or minus 10, plus or minus 2, and a plus or minus 5, and a plus or minus 4. So there's so many different possible combinations here. It may take a while to go through and find one that works. So I think I've found one that works here. We want to check it. I found that 3x plus 5 could be a factor, and x minus 4 could be a factor because the first 3x times x does give us the 3x squared, and the plus 4 and the plus 5 and the minus 4 does give us the -20. So by using the FOIL step for checking, we find that 3x times x is 3x squared, the outer is negative 12x, the inner is positive 5x, and the last is negative 20. By combining those middle terms, we get 3x squared minus 7x minus 20, and we see that does give us the correct middle term. So the correct factored form is 3x plus 5 times the quantity x minus 4. For these examples, we want to factor each perfect square trinomial completely. Now, these types of trinomials are special because they form a perfect square trinomial, where the first term is a perfect square, the last term is a perfect square, and the middle term is twice the product of the first and the last term. So in those cases, we can find the factor if we recognize this pattern. For example, the perfect square trinomial a squared plus 2ab plus b squared. The a squared is the square of the first term. That's a perfect square. The last term is the square of the last term, b squared. And the middle term, if you take a and b, that's twice the product of the binomial's first and last terms. So in factored form, that is a plus b, that entire quantity squared. So for example A, we have x squared plus 2x plus 1. X squared is a perfect square. That's x raised to the second power. And 1 is also a perfect square. That's 1 raised to the second power. Now if we take our x and 1 and multiply those together, the product of x and 1 is 1x. But we want twice the product, which is 2x, and notice that's what we have in the middle term. So this is a perfect square trinomial, and the factor is x plus 1 times x plus 1, the entire quantity squared. And you can check this solution by using FOIL. We know that x plus 1 times x plus 1 is the same thing as x plus 1 quantity squared. By checking the first, the outer, the inner, and the last, we find that this can be simplified to x squared plus 2x plus 1, which is what we started off with. So this is one of those special perfect square trinomials, and when you look at these, you look to see if the first term is a perfect square, the last term is a perfect square, and that middle term is twice the product. So let's look at example B. The first term is a perfect squared. 4x squared is the same thing as 2x to the second power. The last term is 9, which is also a perfect square, which is 3 to the second power. And if we take the product of 2x and 3, we get 6x. And then when you double it, you get 12x. But we want to make sure that middle term is a negative sign, so we can look at negative 3 raised to the second power is a positive 9. So the product of 2x and negative 3 would be negative 6, and twice that would be negative 12, which is what the middle term is in our problem. So in factored form, we can write this as 2x minus 3, the entire quantity squared. Check this by using the FOIL method of 2x minus 3 times 2x minus 3. The first is 4x squared, the outer is negative 6x, the inner is negative 6x, and the last is positive 9. By combining the middle terms, you get 4x squared minus 12x plus 9. So we know that the correct factored form is the quantity 2x minus 3 squared. In example C, we have the 25x squared plus 60xy plus 36y squared. 25x squared is a perfect square. We could write that as 5x to the second power. The 36y squared we can write as 6y to the second power. Now if we multiply 5x and 6y together, we get 30xy, and if we double that, you get 60xy, which is the middle term. So this is a perfect square trinomial, and it can be written in factored form as 5x plus 6y all to the second power. You can check your work here by using the FOIL of 5x plus 6y times 5x plus 6y, and we get 25x squared. For the first, the outer is plus 30xy, the inner is plus 30xy, and the last is plus 36y squared. By combining the middle term, we have 25x squared plus 30xy plus 36y squared. So our correct answer in factored form is the quantity 5x plus 6y all to the second power. For these problems, we want to factor, but let's factor a GCF first, the greatest common factor. For example D, 16x to the third minus 8x squared y plus xy squared. Notice that all of these terms have an x in it. Only two of the terms have a y in it, so we'll begin by factoring out the x. And when you factor out the x, you're dividing each one of those terms by x, taking it out. So what you have left is what goes in the factor, 16x squared minus 8xy plus y squared. Now we notice that this factor 16x squared minus 8xy plus y squared looks like a perfect square trinomial. So perhaps we can write this as 16x squared is the same thing as 4x, all of it squared, and the y is the same thing, y squared is the same thing as y to the second power, and we want the product of 4x and y is 4xy, and double it, we get 8xy. But notice that middle term has a negative in it, so we're going to need to take care of that by making that negative y quantity squared, so that we end up with the product of negative 4xy doubled to get negative xy. So in factored form, we can write this as x times the quantity 4x minus y, all of it to the second power. And you can check your work here by multiplying out 4xy minus y times 4x minus y. And then after you do that, you will get 16x squared minus the 4xy minus 4xy. That would give us a minus 8xy plus y squared, and then distributing the x to get 16x to the third minus 8x squared y plus xy squared. And that is what we started off with. So in factored form, that polynomial can be written as x as one factor, and the other factor of 4x minus y, that entire quantity squared. Let's do example E, 5x to the third minus 10x squared plus 5x. We'll begin by factoring out the GCF. All of these terms have a common factor of 5x. So we'll write this as 5x times the quantity x squared minus 2x plus 1. And this is a perfect square trinomial. So we can write this in factored form of x minus 1, that entire quantity squared. And you can check your work by multiplying out the x minus 1 squared. So that would be 5x times x minus 1 times x minus 1, or 5x times x squared minus 1x is minus 2x plus 1, and then distributing 5x to the third minus 10x squared plus 5x. That's what we started off with, so we know that is our correct answer. In example F, we have 2a minus 24ay plus 72ay squared. The GCF is 2a. So we're going to factor out that from each of those terms. And when we do that, we're dividing out each of those by 2a, and that will be 1 minus 12y plus 36y squared. And this is also a perfect square trinomial that you can factor, leaving that 2a out in front. And this is going to be 1 minus 6y, that entire quantity squared. You can double check that by multiplying out the 1 minus 6y quantity squared, 1 minus 6y times 1 minus 6y. And then we have the FOIL step 1 minus 6y minus 6y is minus 12y plus 36y squared. And then finally distributing back that 2a that was our original GCF, and we would get 2a minus 24ay plus 72 ay squared. So our answer in factored form is 2a times the quantity 1 minus 6y, that entire quantity squared.